let's get to what we're here for, learning together in community. And I'm so excited to introduce you to our local lunatic, Sherry Adams.
Thank you again, everybody, for coming, because it makes such a difference learning with each other. So I just need to tell you that this friend of mine has over 35 published articles. I met him in 1993. He is the reason I'm a lunatic. He's the one who got me started. And since then, I've been able to help him on and off, including in the wintering grounds. So that always is. So basically, this man has been everywhere. If there's a loon and there's some new stuff going on, he's been there on the cutting edge. So give him a welcome to Tuesday Group.
All right, thank you, Sherry. And can you hear me in back? How's the volume? Mostly good, awesome. And earlier I'm a little nervous because Sherry said, you know, be prepared for a great presentation. And remember the saying, with great expectations come great disappointments. So I keep the bar low, makes me happy. Low bar, low ceiling. All right, super duper.
Just double checking.
So this is going to be the outline for today's talk. I'm going to talk, one of the themes throughout the book is about natural selection, and that every aspect of a loon, from its breeding ecology to its winter survival, has been shaped by natural selection over eons of years. So I explained quite a bit of that in the book. The second aspect is the latest and greatest findings. So as Sherry's mentioned, I've been working on loons for 30 years. I've been in touch with other loon researchers across North America, and I have access to to basically all their information. So what I tried to do in this book is share with you the latest and greatest things we've learned about loons in the last 30 years. So I'll share some of that with you this afternoon. And then the last thing are stories from the field. I've been at this for such a long time. I've had some pretty amazing experiences, and I'll just share just a few of those with you tonight. So just a real brief background on myself. I started studying loons full-time in 1993. You might notice that picture in the top left. I was handsome back then. I'm not sure what happened to me, but things changed. That's great. And one of my greatest thrills was studying yellow-billed loons on the north slope of Alaska. So this is one of my happy moments, happy places, where I would see caribou and Arctic fox. And for someone basically born in Motor City, Detroit, it was the thrill of a lifetime. And then this is me studying the anatomy of loons at the Smithsonian Field of Natural History in Washington, D.C. And I've taken some of my loon works to look at some anatomy as well. So that's some brief background. This is us in the early days trying to perfect the technique catching loons. I know folks from Minnesota DNR, Wisconsin DNR were very close during the 80s in almost figuring out a consistent way and reliable way to catch loons. Ultimately, I had a college classmate, Dave Evers, who asked me to help him as part of his master's degree to figure out how to catch loons. And ultimately we did. We figured with a marine battery and a bright candle powers, spotlight, 1,000,000 powers, a large net, and then we had a tape recorder that made a chick distress call, something like, not the greatest, bear with me. But that was enough to keep the loons on the surface. So the adults with chicks were very curious, very protective of their young. They stayed on the surface, and that allowed us to scoop them up. So once we had a loon in the hand, that is quite a large bird to handle. There's a long story there how you best handle a loon, but I can probably show you that tomorrow. And then once you have an organism in hand, as a biologist, you want to gather as much data as you can. So first of all, you take like morphometrics. You know, so you're looking at kind of the shapes of the wings, the bills, the feet. At the same time, you might take access to its blood and its feathers to look at ecotoxins that might persist in the organism. So this is us taking a look at body mass, bill size, bill depth, and wing surface area in relationship to body weight. But the real breakthrough came with putting on color leg bands. So once you could put colored bands on loons, you could then follow them year after year after year. And it's analogous to watching two chickadees or blue jays in the field without knowing males and females, whether they're the same birds that come back year after year. Our knowledge was limited until we can really figure out a way to consistently band birds, mark them, and then follow them for 5, 10, 15, 20 years. So this really opened up the floodgates. And what I'm sharing with you is literally all the information we've gained since the early 1990s when we've consistently banded common loons. So these are places I've worked in field seasons. Field seasons for me might be the shortest would be 1 week. Most of them were 3 weeks to 3 months, and some of them were 4, 5 months, 6 months long. So I worked up in northern Saskatchewan for 3 field seasons. I've worked in Washington State for 4 field seasons. Southern California, what are loons doing in Southern California? They're trying to get in Hollywood movies, and so they're kind of doing their best. And so we saw some loons down in Southern California. 7 years off the coast of Louisiana. 7 years I've been working on a freshwater reservoir in South Carolina where loons migrate, many of them potentially from the Midwest, down to that area. So that's been a wonderful study area. 6 field seasons off the coast of Maine and 12 field seasons in the Midwest. I spent 3 in Michigan, 3 in Wisconsin, and 6 in Minnesota. So that makes me about 60 some plus years old, which would be about right. And I've been really fortunate to work on some other species besides commons. I've worked with yellow-billed loons, yellow-throated loons, Pacific loons that you see in the top corner. I have not worked with Arctic loons, and I'm not sure if time's running out for that one. But in places where I've worked for some of these birds, yellow-billed loons I studied on the North Slope of Alaska for 2 field seasons, and I had a project in Russia for two field seasons. And then also in Chesapeake Bay, I studied red-throated loons for a winter. So just to give you some background on places where I've worked. So let's look at natural selection in loons. So as a scientist, I always ask the question, why? Right? And I think anyone with curiosity, there's been a book written about the curious naturalist, just asking questions. So when you look at a loon here, we might ask, why the red eye? Why the necklace? Why the checkered back? And then we can look at the skull and the skeleton of a loon and ask similar questions. Why are they shaped the way it is, for example? So this is looking at the attachment of the vertebral column to the skull, looking at the angle at which it comes in. This is the sternum or the breastplate of a loon. Why is it shaped the way it is? And then these are the ribs of a loon. There's 8 pairs of ribs of loons, and you have these long extension bony processes that we can see right here. And we might want to ask ourselves, for example, what purpose do those serve? So those are the why questions of a scientist, and they're never ending. I have more questions almost today than I had 30 years ago. And I think that's the example of good science, that you're always generating new questions. So for me to explain loon behavior or loon ecology, I'm really looking at a bucket of natural selection. So how does natural selection shape behaviors and seasonal behaviors of common loons, for example? And natural selection is going to work on an organism that's going to maximize its survival and its reproductive success. So if there's a behavioral trait or an anatomical or plumage trait that's going to help individuals survive better with those traits than without, selection tends to work in that field, in that direction. So when you're looking at survival for loons, one thing that strikes me is foraging efficiency. Loons that can forage more efficiently than other loons, other individuals, are more likely to be selected for. Similarly, we can look at reproductive traits. Traits that are going to help loons protect their young and raise more young, such as vigilance behaviors, those would be selected for. So over time, we would see a shift in some behavior and potential anatomy in common loons. So a very straightforward example potentially could be the large web. So because loons are foot-propelled swimmers versus wings like penguins, a larger surface area, for example, the webbing of the foot is going to propel the loon faster underwater. So we might see selection for larger feet, for example, larger webs, more flexible toes to elongate them, for example. And we do know that common loons have been around for over 1 million years. So if you look at the paleontology record, loons in their current form have been in existence for over 1 million years. So that's over 1 million years in terms of selection operating on common loons. So here's a question we might ask in the approach I take in the book on the chapter in migration. So in the interior of the continent, Minnesota, Wisconsin, for example, loons winter in the ocean. So the nearest ocean, or it seems the direction that many of the Midwest loons take, is directionally south. So they may fly over 1,500 miles to get to the Gulf of Mexico. Loons in New England, for example, Maine, New Hampshire, literally only have to fly a short distance to get to the North Atlantic. So that might be a short distance migrant, might be 150 or 250 miles. So what happens with loons that are from the Midwest compared to loons that are in New England? So this is fuel efficiency. So for this, if you're traveling long distance, you're going to look at something that's aerodynamic, streamlined. It's going to, in this case, we can see which one of these might have to be better aerodynamic. And also you're going to look at weight, for example. So if we look and compare the comparisons, if you're an engineer looking at the design of these two vehicles, and if your goal is to do something long distance with minimal amount of effort, then you can see being lighter is going to help your efficiency and also being more aerodynamic. So if we compare mileage of these two vehicles, we all know that there's a difference. So this is kind of an approach you might take to looking at loons that are in Minnesota versus loons that are in New England. So we're really asking ourselves, are long distance migrants lighter than short distance migrants? So are Minnesota, Wisconsin loons smaller than loons in New England? So let's look at the data and see what we come up with. So if you look at just females, you can see Minnesota and Wisconsin loons are considerably smaller than loons in New England. In fact, 35% smaller. And I was just talking with some people in the room about how Minnesota loons look so large, and they are large. But I've worked in Maine now for over 10 years, and Maine loons are nearly almost double the size of loons in Minnesota. So when I'm holding a Maine loon, I'm really working hard to contain it. And if you look at male loons, you can see there's a very similar pattern. Males are larger than females across the globe, but you see the same trend as well. So in terms of cost of transport, we can ask ourselves, are Minnesota, Wisconsin loons smaller than New England loons? And we would say yes. And the answer for that more than likely has to do with efficiency. So cost of transport, being lighter, you're able to walk further. So for example, if I'm going on a 5-mile hike, and I'm trying to time myself and go efficiently, and I carry a 45-pound backpack, I'm going to be much more efficient, right, without the backpack. So selection favors, for small body size and long distance migrants. But why are short distance migrants so large? Like, what is pushing selection in this direction for loons to be larger in body size? So let's take a look at that. Why the larger size in New England loons? And what we see is loons compete for territories. And larger body size more likely assures your space, your ability to defend the territory. So that's more likely what's happening. So larger body size is more likely to retain your territory versus an intruding loon, for example. So one thing that we also need to address with the body size question is that loon wings are about 20% narrower, for example, this distance here, for a bird of its body size. So why are loon wings narrow? So when we see them perform their wing flap, they're a little narrower than other birds. So why might that be? Well, this is Da Vinci, and he did lots of amazing work thinking about airplanes. And he was noticing as well that you really want to have, for example, thank you. You really want to have larger body size. I mean, not a larger body size, you want to have larger wings, broader wings to increase your surface area. So selection should favor, in this case, I mentioned larger surface area to volume, so you're able to get lift. So this is, of course, what the Wright brothers had done. Large surface area on the wings, as small as material, lightweight as possible, so they could achieve lift. So in terms of a flying machine or a flying bird, that's what we are expecting for loons as well. So to maximize efficiency in flight, that's what we would expect for birds. And most modern birds fit that category. But loons don't fit that category. And the reason for that is loons are selected to be hydrodynamic. They're designed to be efficient in the water, for example, not the air. So that's the trade-off. So with efficiency in the water comes some inefficiency in the air. And I'll give you an example of that. So in this case, loons spend literally 99% of the time in the water. And if we look at the wings, for example, we can see that the wings are held very close to the body. And in this picture, you can kind of get a better idea of it. So if the wings were longer or the wings were broader, right, they would stick out from the body posterior or maybe ventrally, and that would create drag. So all of us know if you have a vehicle, you tow in a canoe or a kayak, that's going to create drag, you're going to get poorer mileage. So for loon to maintain efficiency moving through the water column, having the wings suppressed close to the body and narrower so they fit reduces drag. So with that, though, the trade-off is it's harder to attain lift. Now look at the difference in the keel between a loon and pigeon. So we look at the sternum or the breastplate, and then there's a keel where chest muscles are attached to. And so for a pigeon or a chicken or turkey, which most of us recognize large breast meat, we see lots of pectoralis muscles, chest muscles. But if you look at a loon, you can see it's just a very, very narrow sternum, and there's very little place for chest muscles to attach. So the trade-off, because there's minimal room for chest muscles, it's going to be difficult to attain lift because you lack the powered flight muscles to get you to the top. So the consequence of that, the trade-off, is loons have very high wing loading, so surface area to volume is shifted, and it's very difficult for them to attain lift, as most of us have seen. So it may take them 3 or 4 soccer fields up to a quarter mile in order they can get enough lift. So now the latest and greatest findings. So this is in no particular order, but some things I mentioned in the book as well that you might find of interest. So Dave Evers and his group at Biodiversity Research Institute, folks from Wisconsin DNR, collectively have now color banded over 9,000 loons over 30 years. So now there's a preponderance of data in banded loons that are out there. I'll share with you a real brief story. I'm banding loons in South Carolina at this freshwater reservoir. And just last week, I get a photographer from Minnesota sends me a picture, and it's the color bands and the 7-digit number you can read on the band from my birds that were caught in South Carolina. It was at Upper Cormorant Lake. And that's the value today of taking pictures and sharing photographs. It's just like that. One of the birds that we color banded in South Carolina ended up at Cormorant Lake. And I just found this out just the past week. So let's look at all these loons that have been banded and followed. So then we can kind of answer these questions. You know, do they pair for life? Do they switch territories? Do they return to their natal area as chicks? How long do they live? And what are parental roles like between males and females? So first of all, we can see on our breeding lakes, the return rate is approximately 80%. So 80% of the times, those loons in your corner of the lake are returning. Annual survival rate for loons is roughly 92%. So loons live a long time, and the probability of living consecutively is very high. Now, they do not mate for life. Oftentimes they have 2+ partners. So we've seen evidence of that multiple times. The average duration of the pair bond is 6-7 years. So whether humans get a niche 6-7 years, I don't know, maybe loons 6-7 years. So maybe something like that. So we get an idea. Now, the longest pair bond was 25 years. It was roughly 17 years, but one pair in Sydney National Wildlife Refuge had remained together for 25 years. So the first year of breeding for males, because we banded all these chicks and all these males and females, we know is 5 to 6 years, and for females, it's 6 to 7 years. So it takes literally 6 years for a loon chick to get established on a lake and get a territory and start breeding. And some of the oldest loons, I helped Dave band a loon chick in 1989 that's still living, and an adult female banded in 1992 that's still living and still breeding. So if we do the math, over 35 years, which is pretty impressive. So I'm not sure where the upper ceiling is going to be. Stay tuned and we'll find out. Volume 2 book coming soon. Actually coming in about 10 years. Okay, so not all loons, though, we know make it to 30 years. So we banded lots of adult birds, we followed them, and then it seems like year 22, 26, 27, they don't show up again. So maybe they move potentially to another lake, maybe they're driven out, for example. Or maybe they passed away. Yes.
You able to see the bands without capturing them again?
Yeah, so the question is, can we see the bands without capturing the birds? And that's an excellent question. Yes, we can. It takes a lot of work, but most of us recognize loons roll preen, they roll over on their bellies, show their white bellies, and they stick their leg out. That's when we can see the bands, for example. When they're preening, we can see the bands. And it takes quite a bit of effort, usually about a half hour per pair. So if I show up on a lake with a spotting scope, I might take about a half hour to get the reobservation of the bands. But we're able to do that without recapturing them. And then this one, not all pairs are equally. So roughly 25% of the pairs produce roughly 50% of the chicks. So that suggests that some parents maybe are better than others, maybe they're in better territories, whatever that situation might be. That hasn't really been investigated in detail, but that's the pattern that we see. Not all loon parents are equal. And I thought this would give you some perspective. So generalizations, but for the most part, it's the data are pretty tight. So loons, let's say, start breeding at age 6. Let's say they live and reproduce up until 26 years old. So that's roughly 20 years. What we found studying and monitoring loons over a long time, generally one pair fledges successfully every other year. So loons literally about 0.5 chicks fledge successfully per year. So if survival to age 3, because loon chicks incur mortality during migration and during the winter, that's roughly 0.5, what we learned over 3 years. So that means that loons would produce about 5 adults per lifetime. So even though they're roughly 20 years of reproduction, they're only 5 adults. So that tells us loons have what we call low reproductive fecundity, right? They're closer to elephants and blue whales than they are mice and shrews and rabbits. So if something happens to loons in terms of the population, it's going to take a long time for the population to rebound. And strong data that loon chicks return to the natal area, oftentimes within 2 miles, but sometimes as far as 10 or 15 miles. And the data that Walter Piper was able to see that most of the time females tended to disperse further than males. So male loons know their neighbor's yodel. So I'm going to play a yodel for you. So here's the yodel. Okay, now we're going to play it once more, and this is what I want you to watch for. So just before I'm going to go back. Notice on the loon yodel, this is a pictograph of the sounds that are being produced. There's an introductory note. So the introductory note is, hey, you, and then now I give my message. So many birds will have an introductory note, the song sparrow, dee, dee, and then it gets your attention, and then there's the message. So now I'm going to go back and play the loon call, and we're looking for the repeated patterns. So after you hear the introductory note, listen to the number of repeated patterns. So let's see if we can pull this off. And let's see if this works. Sugar pops, Batman. Hey, I got an idea. Let's try this. Try it. Thank you. Okay, thank you. I think that'll work. So what we're seeing, for example, are those repeated patterns. So the reason I wanted you to look at that is what researchers have done is the male loons on the lake know all their neighbors. They know all their neighbors. They're very comfortable with them. So let's say you go out, for example, and scoop up Elton, whoever Elton is. Let's say you scoop up Elton John. What a great win. You scoop up Elton, remove Elton, and you place another loon there. And not physically, but you play a tape of a loon. What does the original neighbor one loon do? So in terms of a stranger, you can see that the repeated patterns go from literally 4 to like 12. So this is conveying to that loon that I know you're a different loon. I know you're there. I want you to know I'm here. I'm willing to defend my territory. And we see shifts in that. And there's been quite a bit of breakthroughs with loon vocalizations. And I kind of hit on some of them during the book. An oft-asked question is how deep can loons dive? These are some loons that were caught in Minnesota and Wisconsin by Kevin Keenal in the USGS. They went to Lake Michigan. And this is looking at, for example, the dive profile of a common loon. So this is going from 9 o'clock in the morning to like 5, 6 at night. And this is the dive depths. That's the surface, for example, right? And that's the bottom. And what you're finding is that loons are consistently diving 150 feet. We're coming back up, 150 feet, back up, 150 feet, back up, wait for a few minutes and repeat this pattern throughout the day. So this suggests during migration on Lake Michigan, these loons they discovered are feeding on goby, which are the benthic fish. And that explains the patterns that we see. So to give you some comparison between dive depth and duration in loons, we have very solid data from penguins. So I'm going to compare loons with penguins for a second here. So if you look at different sizes of penguins, small, medium, and large, little, medium, or big, when we look at the weight of them in grams, we can see 1,000 grams, 3,000 to 6,000 grams, and 7,000 to 9,000 grams. 4,540 grams is about 10 pounds. So this is roughly like a 10-pound loon, which would be like a Minnesota loon. And if you look at these, for example, you can see in terms of dive depth, that little loons will go about just 100 feet, medium-sized penguins, 300 to 600 feet, and large penguins, 800 feet or more. And if you look at how long they can stay underwater, you can see little loons are roughly a minute, medium-sized loons are 3 to 6, and they're penguins, thank you, yes. And large penguins are 8 minutes. So I feel pretty confident that loons being medium-sized and some of the data we have suggest that loons can dive 3 to 6 minutes and probably dive to depths to 300 feet or more, for example. The other thing that we've noticed is that loon partnerships and each individual contribution to that partnership in terms of nesting, looking after the young varies. So I wrote, not all loons are equal. So if I just show you this graph, I'm looking at how much time you incubate the nest, how long you look after the chicks, how much you feed the chicks. I looked at loon pairs for 18 hours per day over the course of the summer for 11 pairs. And I was looking to see parental involvement and role. So if you were 50-50, if everything was shared 50-50, you would be right on that line. And what you can see, for example, there's probably 5 pairs where females did much more work than the male partners. And in some cases, male partners did considerably more work than their female partners. So it wasn't 50-50, but there was quite a bit of dynamic fluctuation. And for those of us who have had children, we know all about that. Someday, hey, I'm just not on my A game, but don't worry, I got it. You're all taken care of. So this is the dark side of the loon. So, loons are pleasant, loons are wonderful, but at the end of the day, loons are also highly aggressive towards conspecifics or towards other loons. And we also see them chasing heterospecifics or non-loons. We've seen them chase mallards and mergansers. They can be highly aggressive. So especially during the incubation cycle, they could be very aggressive. So this is one loon chasing another loon, for example. And this is the sternum of a loon collected from a necropsy by Mark Pokers at Tufts University. And you can see there's sternal punctures, there's holes in there. So I went to Mark's place, he took a loon, stuck the bill right into the hole, and it matched up perfectly. So this is the CSI detective work. So we do know, right, that loons can puncture other loons. And so basically they're coming underneath. The loon's on the surface, they swim underneath and just periscope and come straight up into the sternum of a loon. Sometimes outright killing them, that's rare, but it does happen and has been documented. And the thing that was really fascinating for this, so literally half the loons had sternal punctures. So Mark has done over 4,000 necropsies of loons, and of those, half have had sternal punctures. So that tells you this is part of the life cycle of loons, is its aggressive nature. The other thing, and moreover, which is going to shock us in this room, shocks me, is that females had just as many sternal punctures as males. So normally we think aggressions in males, testosterone levels are high, but we see female aggression. And I don't know if how much male aggressiveness takes place. But just the fact that half the female had sternal punctures is really fascinating. So the other thing that we've learned is winter site fidelity. So roughly since 2004, I've been spending a lot of time studying loons in the winter, up in the rivers of Washington, southern California, Louisiana, Massachusetts, South Carolina. And what we've seen is that loons exhibit winter site fidelity. So about 85% of the time, loons go back to the same site winter after winter, same locations. This is a bird that I banded in 2004. This is the photograph of the bird in 2020. And a photographer has been out there getting repeated band return rates for me for 17 years, which is pretty remarkable. So that loon has gone back to the same part of the same bay for 17 years. And then some of you may not be aware there was a loon translocation effort roughly 10 years ago in Minnesota. And so the idea was to look at, can translocating loons be a conservation tool for loons should the need arise? So we see some retraction of loons from their range, shifting south to north. And so there was some interest in wanting as a conservation tool that's been used for other birds. Could loons potentially be released from a southern lake, and rather than return to the northern lake, go back to the southern lake and potentially breed there? So that was really the question that was being asked. So loons were ultimately moved from Grand Rapids, northern Minnesota to southern Minnesota. So the source lakes were Grand Rapids area. And we always took one of the chicks from the two chick broods, and we took the larger chick. And then we released them on Fish Lake. And this is the study site. This is in southern Minnesota. Fish Lake's very small lake, very private, very little shoreline development. And ultimately we settled on building a large pen for the loons. That was a process in itself. This is the first chick that was ever released for Common Loons, and you can see the date was 15 August 2014 at 4:35 in the morning. And this is me releasing the chick into its pen. So in terms of the enclosures, we saw we used a large steel mesh. We were trying to keep out anything imaginable. For example, we had avian guards to keep out birds, for example, like eagles. We had large steel mesh, avian guards, aquaculture netting, and we had a visual barrier because we had several of these concurrently. And we found out that we needed that so the loon chicks weren't calling to each other all the time. So we tried to take chicks that were 6 to 8 weeks of age, that were mostly fledged, mostly independent of their parents, but still dependent on their parents to some degree. And then we tried to figure out the best way to deliver food to them without them imprinting on people. And we came up with a variety of techniques. A large PVC pipe, we would kind of ultimately push fish down. We would cover ourselves as we approached the pens. And we tried using little netting as well. And we found that if we slapped the surface of the water with the fish, that the chicks would come over and basically get fed, for example. So this is what's happened. And then we monitored them. So once we fed them, we always had someone monitoring them literally almost throughout the day. So 20-minute observation periods per hour. We recorded all their behaviors and we just kept an eye on them for weeks and weeks, for example. And then we thought they were ready to fledge. We fledged them. Before we released them, we took blood measurements, made sure they were healthy, for example. And then we put a radio transmitter on them so we could track them. And then we did a soft release, and ultimately they fledged then from Fish Lake. So this work continued in Massachusetts. So concurrently, just the year following our initial work in Minnesota, we started this in Massachusetts. And we took loon chicks from New York and Maine, for example. And the chicks in New England, and I think it's because it's closer and there's been more volunteers and field workers there. The group from New England was able to show that these chicks ultimately came back to their release lake and then ended up breeding in the surrounding areas and it bred successfully. So as a management tool, it's actually worked in New England. In Minnesota, we've seen some of the chicks return, but we're unclear whether they have bred or bred successfully. Okay, so now lastly, stories from the field. And let me just check my time, as every good speaker does, right? Okay, go really fast. We'll get it. So I think we're good. So stories from the field. So here's one I'll share with you. So in January 2012, I'm studying loons down in the Gulf of Mexico. Part of it was in the wake of the BP oil spill. So here's some loons in the bottom left-hand corner, for example. And it was really hard work. My gosh, I got to see spoonbills and pelicans and black skimmers. Be out on the, why it's 20 below in Maine, I'm out down there in the Gulf of Mexico struggling with my radio transmitter work. But someone's got to do it. So, and one of the coolest things that happened was I would see dolphins and loons interact quite a bit. Now, dolphins are cetaceans, right? You got loons. And just kind of those two birds being together was just awesome to see. So let me share with you a little brief story that I have from this. So I have had many amazing encounters with wildlife and observed a lot of fascinating behavior, but this story ranks up there as one of my most memorable. In January 2012, I was doing winter loon surveys off the Louisiana coast and the Gulf of Mexico. My mind was struggling to comprehend how loons could find food in this environment. They are visual predators, and the murky water must have made it extraordinarily challenging to locate prey. We were in a series of channels dotted with islands when we spotted a bottlenose dolphin. Any dolphin sighting makes for a great day, but this one was acting peculiar. It was swimming toward shore and then would swim back to the middle of the channel and repeat this maneuver. What was it doing? We could see ripples of water near shore from fish racing away from the dolphin. It must be pushing the schooling fish to shallower water to increase its foraging odds. That's it, we shouted. Amazing. So in other words, the dolphin was swimming toward shore, herding fish, and would come around and repeat this maneuver. And then some of the fish were kind of on the periphery of that, trying to get away from the dolphins. Then we saw a common loon follow in the wake of the dolphin as it moved toward shore. At first, we were skeptical, but the longer we observed, the more certain we were that the loon was consciously swimming back and forth each time in the wake of the dolphin to get any fish that were escaping the dolphin. This behavior did not look cooperative by any means. It simply looked like the loon was aware of what the dolphin was trying to accomplish. And that was just like, go figure, right? So one of those cool moments. And this is a story from Walker Lake, Nevada. So Walker Lake, Nevada is about 11 miles long, 5 miles wide. And it's roughly 70 miles southeast of Reno. So what the heck was I there for? Loons in Reno, gambling? I don't think so. So let's take a look at this. Over 1,000 loons during the spring and fall are counted on Walker Lake. It's used as a big staging area. So during migration, they stop there and they're feeding on tule chub and the haunt and cutthroat trout, ideal prey items for loons. And so we were called in to try to implant satellite transmitters on these loons to figure out where they were going. And part of this was an effort by the Nevada Fish and Wildlife to just get other agencies and groups working together to try to give some support for this area. And the reason they were looking for support was this lake has been drying up. It's dropped 40 feet in 40 years. And as it's dropped in sea level, dissolved solids are going very, very high. So if you're a fish and you're trying to use your gills to extract oxygen from the water, if it's so murky and with so many dissolved solids, that gets harder to do. Your survival is going to decrease, reproductive success is going to go down, ecosystem might collapse. And so this was a very strategic part by Nevada Fish and Wildlife to get a bunch of players involved. So, time for a story. Okay. So wildlife research involves moving parts, and sometimes things do not always go according to plan. Here's a good example. In 1998, Dave Evers and I were at Walker Lake, teaming up with researchers Mike Yates and Mark Fuller from Boise State University, Larry Neal from the Nevada Department of Wildlife, and Kevin Kenow from the U.S. Geological Survey. Each team was there to do a very specific job. Mike and Mark from Boise were the leaders of the project. The team from Nevada had the boats, the drivers, and the expertise to navigate us around the lake. And the USGS staff were responsible for conducting the surgeries and implanting the satellite transmitters. Dave and I were there to catch the loons. So we all met the third week of April. And so those of you know who do it like wildlife research with different moving parts, You just have to pick a date. At some point, you gotta just, this is the date, this is the time, here we go. So that's kind of some background for this. So we went through introductions, discussed the plan for the next few days. The Boise State team notified us that the satellite transmitters were not in hand and would arrive the next day. So we questioned whether to put off going in the boats until then. But strong winds were forecasted each evening, and going out in the lake would be potentially dangerous. The winds from this region are known to howl down the mountain and through the valley, creating large whitecaps and dangerous conditions. So we tossed around our limited options, but ultimately we decided, let's just see if we can catch these loons. So during migration, adult loons do not have chicks next to them. So parental instinct to protect and guard their young is no longer exist. So what's to prevent loons from just diving when you shine a bright light on them? Well, nothing. So that means we're going to have to try to catch loons, and it might take us a very long time to be successful. So ultimately, we decided to go out. The hard work continued. When we did locate loons, several of them dove, focusing us to search elsewhere. But a few paused upon seeing the light, and thus gave us a chance to net them. We caught 5 loons that night, but we were faced with the hard reality that the satellite transmitters would not arrive until the next day, and we had no place to keep the loons overnight. So did we release them and try our luck tomorrow? But what if the weather conditions worsen, as expected, and then could we even launch our boats? So loons are big, hardy birds, and with our collective experience, we felt the loons would be fine if we kept them overnight. But where? With limited options, we had reason to take them with us to our hotel room. Was this seriously going to work? Seriously, did the hotel managers know that we would have an additional guest in our room? And then I tell more about that story, what happens, but it turns out well in the end. Sugar pops. Hang on, okay. Hey, what did I do? Let me see if I can. Why is it doing that? Yeah, oh, sugar pops. No, wait, that's the Brook answer. That's good. Hey, folks, we're all good. Just, senior moment, it's all good, right? I was thinking it's good. So this is us doing the anesthesia and work on those limbs. And here's the satellite transmitter. So then we plotted the satellite transmitters from those birds, and they flew to Northwest Saskatchewan. So that was a really interesting part of the story. So then we tried to contact the Saskatchewan government and get involved in some conservation efforts. Now, this could be the end of the story, but it's not quite. 13 years later, almost not quite to the day, in the Gulf of Mexico, we're out catching loons. We're going to put satellite transmitters in them, right? So you're just in the ocean, Gulf of Mexico. We catch some random birds in the ocean. Let's put satellite transmitters in them. Okay, let's mark the GPS. Let's see what happens. Okay, so here we go. This is March 2011. So this is one of the birds. Stayed 10 days in a reservoir in Tennessee. So by day 23, spent 15 days in Lake Michigan. So it migrated 600 miles, 800 miles, stopped, fed for a week to 2 weeks. Spent 6 days in Lake Winnipeg, day 48. And by day 52, almost 2 months, it flew 2,309 miles to Saskatchewan. Interesting. What about the other loon that we caught? So the other loon spent 20 days off the Mississippi coast. Then it made its way to a reservoir in North Carolina. Spent several days, 9 days in Chesapeake Bay. And then 12 days in Lake Erie, 10 days in Lake Huron. Again, 2-3 days in Lake Winnipeg. It took 72 days, but it flew 2,776 miles to Northwest Saskatchewan. So I remembered the work that we did in 1998. No, they can't. No, let's plot the data. Okay, let's plot the data. So we plot the data. We see the dashed line, the solid line, and it looks like they converge in Northwest Saskatchewan. So let's zoom in a little closer and see what happens. So there's Peter Pond Lake, and sure enough, it looks like the loons from Walker Lake and the loons in the Gulf of Mexico stopped and used the same lake in Northwest Saskatchewan. So if we zoom in more on Peter Pond Lake, the thick line is the lake from, I said, Flaghead Lake, that's also Walker Lake. The very thick lines from Louisiana. And you can see they use the same corner of the bay. So I'm not sure if any of you know the definition of this word, but let me finish this real briefly. So loons in Saskatchewan, right, we're wintering both in the Pacific Ocean and in the Gulf of Mexico. So again, I was asking, if you learn your migration routes, how much is environmental, learning from your parents, how much is genetic? And so this is what I wanted to show them. So what are the odds of that happening, right? So at the end of the day, for 30 years, I've been doing this. I've been funded most of those years by Earthwatch Institute, which is a group based in Boston that does citizen science. They've done amazing work, and it allows people with passion to donate their time and money to a wildlife research project. And in the end, they get to help out researchers and gain valuable experience. So I've had 248 volunteers helping me over this time. Sherry Apps was one of those who kept coming back multiple years. I thank her in the book for her hard work. And I've also had the privilege to work with 52 biologists for a minimum of 4 years. These are biologists that I worked with for a very long time. And other biologists, for example, I've worked with for a very long time. I'd like to thank fellow loon researchers who've just done tremendous work. We have a very open relationship, share information. It's been a very useful experience. And of course, I have to thank my family has been very supportive of me traveling quite a bit of time. It's photo credits, my friends Dan and Ginger Polischuk and Darwin Long. I have a website, and thank you for tuning in. And we'll take some questions. All right. Okay, how about you in the back first? Go for it.
What's the longest distance that you know a loon has migrated in a single day?
In a single day, roughly around 800 miles.
Sorry, everyone. I'm gonna turn this one off.
Yeah, roughly 800 miles. Typically 600 to long day. So loons can fly 75 miles an hour. So in 10 hours of nonstop flight, that's 750 miles. Most of them I've seen when I've tracked them, the satellite transmitters will fly between 400 and 600 miles. So that's more of the norm. And I think we had one loon that flew 800 miles. One
Constant flapping, no soaring. They can't soar.
And their wing beats are roughly 240 wing beats per minute. Okay, how about the gentleman with the hat? Hey, we should ask our local loon ranger what they feed on, but mostly what we find they're feeding on minnows as well. So in terms of feeding their fish, cyprinids, they will feed somewhat on panfish, but they will feed on small trout, for example, whatever available. Perch is really, it seems to be a preferred food for them. I think it's because they can probably overcome perch. And then as they migrate, there's alewives and herrings that they'll feed on as well in the wintertime. Sure.
I saw a loon a couple nights ago on Shago when I was fishing, came up and had a pretty good size, maybe a small panfish,
Mhm.
small smallmouth. And it dove without swallowing that fish. And then I thought it might have been disturbed by us. And then it came up a little bit later and the fish was gone. I thought they only swallowed food when they were, above the water. Is that not true?
No, I think most of the time you do see, what were you gonna say, Sherry?
Mostly they swallow it under the water unless it's too big or they're having trouble.
But that's what he was saying. It seemed like it was a pretty large fish. And so most of the time, the large fish, they feed on the surface. Out of some of the necropsies Mark Hokus has done, and I assisted on one, loon comes into the facility and you're trying to do a first analysis of what could have happened. There's no external injuries. So we open up the stomach and nothing looks really wrong. We open up the esophagus and there was a large fish and the loon had choked to death. And so occasionally eyes were bigger than its stomach, for example, but that's happened. But really large fish, they do swallow on the surface, but most of the fish they're swallowing underwater. That's, I think, what Sherry was mentioning. So smaller prey size is underwater. Yes.
The 9,000 birds and loons that you banded represent what portion of the population?
Yeah, pretty small percentage. So there's roughly 250,000 pairs of loons. So that puts us at 500,000 loons, plus all the non-breeders. That puts that number about 600,000, 650, 700,000. So 9,000 is a very, very small portion of that. And so people ask, there's more loons in Minnesota than all the lower 48 states combined. So Maine is second, Wisconsin's third, but Minnesota has more loons than all the 48 states combined total. So go Minnesota. Yes. So the question is, what's their biggest predator? Interestingly, in the winter environment, we've had loons wash up on shore with sharks' teeth embedded in them, tiger sharks. So we do know that more than one. Seals, jaw marks similar to seals. Yeah, I know I'm stalling, buddy. I'm putting you on the edge of your seats. This is a teaching technique I learned. Don't give them an answer. Work at this answer. I want to talk about this. What was your question again? Then you forget. Next question, by the way. Yeah. Hopefully I'm learning how to do that. But in terms of first of all, with chicks, so chick mortality, sure, you have snapping turtles that pull them down. You have large trout, muskie, pike, potentially that can pull a chick down. You have eagle predation that can pick up chicks, right? That's a little more problematic. So in terms of chick predation, that's kind of what fits in. In terms of adults, it's only when when adults are incubating and on nest that they're vulnerable, right? Because they're not in the water where they're king masters of their environment. So when they're incubating, you can't have an eagle that can swoop down and land on them while they're incubating. So in terms of it being a major predator, not at all. 92% survival rate from year to year. So eagles do take some loons incubating, but it's not a population level threat. But those are the kind of main predators for loons in the breeding and wintering grounds. Yes.
How do you tell the difference between a female and male loon?
One second.
And I would also say to that question, sir, that there's also a bunch of mortality factors that have to do with humans, even more than eagles. So lead poisoning from any kind of fishing jig or hook or whatever, and monofilament line, shoreline destruction, boat hits. I mean, there's a whole list that we have, that the researchers have about that.
Yeah. So going back to males and females, so loons have air sacs like other birds. Their feathers are very stiff. So the first time I held a loon, I was impressed by they remind me of woodpecker feathers. They're stuffed with melanin. And the reason for that is because they squeeze their air sacs. So birds have air sacs, and those air sacs can kind of buoy them in the water. But if you're trying to dive, it's like having little balloons underneath with you. So you want to compress the air in those air sacs. So having stiff feathers compresses those air sacs and allows them to dive. Now, that being said, male-female differences, right? If everybody's relaxed on the surface and they're not compressing their feathers, minimizing those air sacs, right, the male is going to be larger, literally 25 to 33% larger. So body mass, it'll look larger. I've noticed the neck is thicker. I've noticed the bill looks thicker. And if you look for those differences, you can tell males and females. With the caveat, right? But if one of the birds are lower in the water because they're compressing their feathers and squeezing their air sacs, they may be lower in the water. So conceivably, you could get it wrong because the male squeezing its air sacs might look smaller, but it's for that reason as well. And we do know only males yodel. So only that yodel is given by males. And out of all the years we've been doing this, we've never had a female yodel.
And females lay the eggs. If you see them lay the eggs, the researchers have told me, Jerry, if you see them lay the eggs, that's a female. The yodel, that's the male.
And by the way, I'm staying with Sherry for the next few days. So if someone wants to help me out, take me to dinner, help me. Yes.
Is all the territorial defense male?
No, it's certainly some level of female. And that's more area that we need to look at, but we're starting to, usually pairs will go around together, but occasionally females, but more so I've seen more males do patrolling than simply females. Yes.
Jackie has a question.
So the question was there an impact from the oil spill? Certainly there was an impact. How large an impact is still being discussed. So there were roughly like 900 loons that were collected from the spill. We thought that would be a much higher number initially than it turned out. We've done some population modeling, so my crews were out looking at oiling on loons. And so if loon has oil on it, the danger is, there's two things. One, oil disrupts the salt gland. So loons have a salt gland that balance their salt levels. So we all know about thermoregulation, regulate body temperature. There's osmoregulation, regulating your salts in your body. You have too few, too high salts, you've got serious problems. So oceanic birds have a salt gland to deal with the salt because their kidney's not efficient enough to do that. So oil disrupts the functioning of the salt gland, which disrupts a bird's ability to osmoregulate, which oftentimes can lead to death. And then the other thing that can happen is oil disrupts the zipping mechanism of feathers. So a lot of the preening is all about really trying to get the feathers to align, the barb and barbios to latch correctly and minimize water getting in. Oil disrupts that mechanism. So then water, chilling water, can get into the skin of a loon and cause death that way. So almost always, there's more loons that die indirectly from oiling than over time than just that initial spill that takes place. So we estimated based on those numbers of deaths and the oiling levels and the amount of oiling levels, and we did not see high oiling rate levels. So like maybe less than 1% of the body might have oiling. And we estimated potentially 4 to 10% of the population might be impacted. So when you looked back at Wisconsin, Minnesota monitoring systems and Ontario, Canadian Lake Loon surveys, we were expecting to see a blimp, a decrease. And we never saw it. We never saw it in Minnesota, Wisconsin. We never saw it in all the Canadian Loon Lake surveys. So I'm not sure what, but that's what the data never did show a blimp. How about in back with the hat?
Johnny,
I'm sorry. I got it, page 32. I'm going to make you buy the book. Page 32. I go into the long discourse. It's very complicated, but I do go into great depth on it. And I can't answer all these questions because, yeah, thank you. Maybe what's our time? Uno mas.
Yeah.
Uno mas. Yeah, how about someone different?
Johnny's in the back. Johnny? John.
Ontario and Common Loon. You know, what happened before this, and this methods of
Yeah, so botulism is a real problem with loons as well. And in fact, over the last 20 years, I think the number is over 20,000 loons have died from botulism. So Lake Erie, Lake Ontario, Lake Michigan, changing gobies seem to be involved. Mussels are part of that equation, part of that story in terms of the botulism toxin. And then loons are feeding on infected gobies and getting botulism from there. So that tends to be a fairly serious problem as well. But with that, and it's always been a puzzle for me, if 20,000 loons have died over 20 years, how come we're not seeing population level dips? And we're still not seeing that despite that, which maybe is a good sign that there's many non-breeding loons in the population that could come in case those breeding loons are taking out of the population. So, all right, so I'm around for the next few days. Right, feel free to find me. I'm at Her's house. Please come find me.